Hello everyone. The topic for today is the distributive property. Right now I want you to pause the video so you can copy down your notes and then resume when you're ready. In our first example, we're doing mental math essentially, where we're breaking down 4 times 34 to two separate multiplication problems using the place values. So what we're going to do is multiply the 4 times times 30, because the 3 is in the tens place, and then we're also going to multiply 4 times 4 because that's in the 4 is in the ones place, and then those two products we're going to add together. The thought process is that 4 times 30 is something that you can do in your head. 4 times 30 gives you 120. 4 times 4 is 16. We add those together, we get 136. Using that same thought process, that's how we're going to apply the distributive property when we have variables. In the first example, we distributed the 4 to the 34. In our next example, we're going to distribute the 3 to x minus 7. Remember, that is the letter x, not a multiplication sign. So we're going to multiply 3 times x. We're also going to multiply 3 times 7. 3 times x is 3x. 3 times 7 is 21. We cannot simplify that. Therefore, that is our answer. Another example of that, here we've got the 4 on the outside of the parentheses. So that's what we're distributing to everything on the inside. So 4 times 5a and 4 times 11. So we wind up with 44, because 4 times 11 is 44, minus 20a. Because 4 times 5 is 20. We could do that multiplication, but we don't know the value of a, so we have to leave it as a variable. There's our answer. Next example involves a few extra steps, but mainly a lesson that we'll be talking about in the future, which is simplifying expressions. But the first thing we have to do is distribute this 2. So we wind up with 3x plus 4 plus 26x minus 40. And now we can simplify that because we have what are called like terms. So 3x and 26x are like terms because both of them have just a regular x. So we can actually add those together, and we get 29x, and then 4 and 40, and technically that's a negative 40, would be combined together, and we get negative 36. But that's another lesson. We won't see any problems like that for this particular assignment. Just wanted to introduce the topic. Next, we have factoring the expression, in which we're going backwards. So we've talked about distributing the numbers on the outside of the parentheses. Well, now we're going to essentially work backwards from what we have. So one of the first things I want to point out is, for this example or a problem like that, a lot of people want to just say, oh, well, the answer is 20. That is not correct. It's asking us to factor the expression. So we have to factor it. It's not asking us to evaluate it. If we were evaluating it, then yes, the answer would be 20, but we're expected to factor it. So to do that, we have to find the biggest number that will go into 12 and 8. So that number is 4. So that's the number that goes on the outside of the parentheses. 4 goes into 12 3 times. 4 goes into 8 2 times. So there's our factored expression. So let's try that again with 32 plus 16x. So the biggest number that will go into both 32 and 16 is in fact 16. So we have 16 on the outside of the parentheses. 16 goes into 32 2 times. 16 goes into 16 once. There's our factored expression. Looking at another example, we're going to take the 3 and we're going to distribute it. 3 times b and 3 times 8. 3 times b gives us 3b. 3 times 8, that's a b. 3 times 8 gives us 24. So we have 3b plus 24. Looking at the next example, we're going to distribute this 7. 7 times r, 7 times 7. So 7 times r is 7r. 7 times 7 is 49. So there's our answer. Now I want you to solve this problem and this problem. Bring those answers along with any questions that you may have with you to class tomorrow.